Hi, this is the Database Management System class. We're gonna study Chapter 1, the database environment and development process. Actually, in this sector, we're gonna study several terminology. So we will define several terminologies of databases, and also we will study limitations of conventional file processing system. Also, we will study advantage of database management systems. And then another important thing is identification of cost and risk of database management system. And also, we will distinguish between operational and informational data management. And also, we're going to study components of database management, system environment. And then we will study category of database applications. And we will study another database system development approach like prototyping and agile development approach. And then we will study the roles of individuals involved in database management system. And also we will study differences between personal, multi-tier, and enterprise data management system. And then we will study three schema architecture: external, conceptual, internal architecture of database system. Actually, we will study the definitions. First one is database. Database is organized collection of logically related data. So, what is the data? Data by itself is not very useful. It is only after the data has been processed, summarized, and organized that it becomes useful for decision makers and knowledge workers in our organization. The processed data becomes information, which is often made available to users in the form of report or graphical displays. And then metadata really pertains to the underlying structures of the data. When you design a database, you are specifying its metadata. When you populate the database, you are putting data into it. So, data is stored representations of meaningful object and event. There are two kinds of data. One is structured data. Usually structured data is number, text, and date, and so forth. Unstructured data is images, videos, and documents. And already explained, information is the processed data in order to increase knowledge in the person using the data. And then metadata is data that describes the properties and context of user data. You can see figure 1-1, converting data to information. A. Data in context. The class roster, course MGT 500. The course name Business Parlors. Semester Spring 2018. Section 2. There are name and ID and major and GPA. Baker Kenneth D. His major management and overall GPA 2.9. Doyle John E. Major marketing, GPA 3.4. Pinko Clive R. Major programming, GPA 2.8. Louis John C. Major management, GPA 3.7, and blah blah blah. Here we see a report that indicates several types of data entities. We have courses and sections of these courses, and we also have the students that are enrolled in a section. Thus, we have gone from just raw data to some type of useful information by organizing the data. The concept of an entity is something we will discuss in detail later. And next page, we summarize data. You can see there are pie chart, percent enrollment by major. So marketing 15%, management 20%, accounting 25%, information system 15%, other 15%, finance 10%. As you know, in this chart, actually in United States, the accounting major and then finance major, they earn lots of money compared to marketing or management or other major. So accounting is popular. And then you can see there are also another graph, some kind of prediction graph. So we can estimate and also the number of students. So this is the enrollment projection graph. Here is the summaries of the data in graphical form. Specifically, we see a pie chart and a line graph. Rather than individual data unit, the data has been processed into aggregate and categories. Sums and averages are typical forms of aggregated data, and this is another way of turning raw data into useful and actionable information. And then table 1-1, example metadata for class roster. So metadata is not data. Instead, it is a description of how data is to be stored and organized in a database. Metadata enables database designers and users to understand what data exists, what the data means, and how to distinguish between data items that at first glance look similar. Descriptions of the properties or characteristics of the data, including data types, field size, allowable values, and data context. So their courses, section, semester, name, ID, major, GPA, and then the types of course, alphanumeric, length, duty, and description, course ID and name, source, academic unit, and then blah blah blah. And then disadvantages of file processing. First one is the disadvantage of file processing system. Prior to the advent of databases, data was stored in individual files. It's being used by several programs. This was the traditional file processing approach to data storage. As business applications became more complex, it became evident that traditional file processing systems has a number of shortcomings and limitations. Database systems were developed to overcome these shortcomings. However, there is still a lot of data that is stored in traditional file systems. Legacy systems still abound with traditional files. Even Excel spreadsheets, which are relatively modern, would fall within the same category as file system. Many companies store their important data in a myriad of spreadsheets, and as their business become more complex, they run up against the limitation of these storage methods. So, first disadvantage of file processing system is program data dependence. All programs maintain metadata for each file they use. Second one is duplication of data. So different system programs have separate copies of the same data. And then third one is limited data sharing. No centralized control of data. And then length, development time. So programmers must design their own file format. Final one is excessive program maintenance. So 80% of information system budget usually uses at programming maintenance. So figure 1-2, old file processing system at Pine Valley Furniture Company. So you can see there are order department and accounting department and payroll department. And also there are several programs, and then there are some kind of different format of same data. So duplication of data and then program data dependency. So custom file, custom master file. There are two kinds of custom master file. So it must be shows duplication of file processing system. So program data dependency. The customer master file is used in the order filing system and the invoicing system. Suppose it is decided to change the customer address field length in the record in the file from 30 to 40 characters. The file description in each program that are affected of the 5 programs would have to be modified. It is often difficult to even locate all programs affected by such changes. And then duplication of data. Note 2 different files containing inventory data. One is used for order filing and the other for invoicing. This duplication is wasteful because it requires additional storage space and increased effort to keep all files up to date. Data format may be inconsistent, data values may not agree, or both. Reliable metadata is very difficult to establish in file processing system. The Fine Valley Furniture Company will be an ongoing case in this textbook. So, we will become very familiar with Fine Valley Furniture over time. And then the database approach. Chapter 2 and Chapter 3 focus on data modeling. Specifically, we'll see and learn how to create entity relationship diagram for various types of entities, attributes, and relationships. Entity relationship diagram help analysts to conceptualize and represent the real-world environment, which then helps guide the database design process. Data model, graphical diagram capturing nature and relationship of data. Enterprise data model, high-level entities and relationships for the organization. Project data model, more detailed view, matching data structure in database or data warehouse. Entities, noun form describing a person, place, object, event, or concept, composed of attribute. And relationship, actually the association between entities, usually one-to-many or many-to-many, but can also be one-to-one relationship. Figure 1-3, comparison of enterprise and project level data models. A. Segment of an enterprise data model. B. Segment of a project data model. Here we see the distinction between an enterprise level data model and the project data model. The enterprise level model is more of a bird's eye view and less detailed than a project level model. Entities are represented by boxes. Relationships are represented by lines between the boxes. Attributes, which describe the important characteristics of an entity, are represented by the verbiage within the boxes. In the enterprise model, the relationship between customer and orders is one-to-many. This means a customer may place many orders, but an order can only be placed by one customer. The cause feed of the relationship line indicate the many side of the relationship. We also see a many-to-many relationship between orders and product. One order may contain many products, and of course, a product could be contained in many orders. The project level model goes into more detail, including attribute, unique identifiers, and additional information about the order line. And also database approach. Actually, we usually call the table as relation. And then there are lots of relations in database. So we call this relational databases. So database technology involved tables representing entities and primary foreign keys representing relationship. The database management system is a software system that is used to create, maintain, and provide control access to user databases. Most current database management systems are in the form of relational databases, which represent data as a collection of tables in which all data relationships are represented by common values in a related table. We will explore relational databases in detail throughout these courses. Note that because all the data is shared in a central database, there is no longer the need for separate system and program to maintain their own copy of the data. This reduces duplication and increases integrity. Advantage of the database approach. There are many advantages of databases over traditional file processing system. First one is program data independence. Second one, plan data redundancy. Third one, improved data consistency. First one, improved data sharing. Fifth one, increased application development productivity. Sixth, enforcement of standard. Sixth, improved data quality. Seventh, improved data accessibility and responsiveness. Next one is reduced program maintenance. Final one, improved decision support. Also, there are some costs and risks of the database approach. Actually, there are also costs and risks. It is not an easy thing to convert from traditional file processing system to database system. Although the end result is usually beneficial to the organization, the cost of converting are significant, especially for a large company. So, new specialized personnel, we need some more personnel. And also, there must be installation and management costs. Also, the increased needs of complexity. And then there must be conversion cost. And then there must be needs for explicit backup and recovery. And then there must be organizational conflict. Also, Figure 1-5 Integrated Data Management Framework. So you can see the integrated data management framework includes both operational and informational data. Operational databases record transactions and keep the company running. Every customer order, every sale, every purchase, every product manufactured, every employee payment, etc. is recorded. Data in operational databases is constantly changing with insertions, deletions, and updates taking place thousands or even millions of times per day. Operational databases are usually relational databases, and this is what the book mostly focuses on. By contrast, informational systems are used to help analysts, knowledge workers, and managers understand what's going on and make better decisions. Some are relational and some are not. Although the book focuses more on operational database management, there is also some discussion of informational. And components of the database environment. The data modeling and design tool, so it is automated tool used to design databases and application program. And repository, the centralized storehouse of metadata. Database management system, usually we call this DBMS, is software for managing the database. And database, stored house of the data. Application program, software using the data. And then user interface, the text, graphical display, menus, etc. for user. And then database administrator, personnel responsible for maintaining the database. System developer, personnel responsible for designing databases and software. And user, people who use the application and databases. Figure 1-6, component of the database environment. The data modeling and designing tool are automated tools used to design databases and application programs. These tools help with creation of data models and in some cases can also help automatically generate the code needed to create the databases. A repository is a centralized knowledge base for all data definition, data relationships, screen and report format, and other system component. In other words, the metadata resides in the repository. Database management system is a software system that is used to create, maintain, and provide controlled access to databases. A database is an organized collection of logically related data, usually designed to meet the information needs of multiple users in an organization. Our database is not the same as a repository. The database contains data, whereas the repository contains metadata. In other words, the repository defines the structure of the data. Application program interact with the repository database to provide functionality of use for the company. Relating this to figure 1-2, the application program fulfills the order processing, invoicing, and payroll function. The user interface includes language, menus, and other facility by which users interact with various system components. Most application programs will involve user interfaces because they will be directly used by people. However, not all applications involve user interface. Some are known as batch program. In the background, for example, a program that print paycheck may not include a user interface. Different types of user include data and database administrators, system developer, and end users. The data administrator manages the data and database. The developer creates the application program. The end users are people who use the system for various business functions. This can include accountant, salespeople, managers, etc. Database administrators and system developers are IT people, and their principal clientele are end users. The database development process. System development life cycle. The traditional system development life cycle came from the days before advanced technology made rapid application development possible. Prototyping and its variants such as Agile, Scrum, and Extreme Programming came about much later in the history of information technology. Many projects combine various elements from system development lifecycle and prototyping. In the next set of slides, we'll look at the steps in each approach. So, the system development lifecycle is detailed, well-planned development process. Actually, it must be time-consuming, but it is comprehensive process. So, it is long development cycle. And prototyping is rapid application development. So we call this RAD. It must be cursory attempt at conceptual data modeling. And it defines database during development of initial prototype. Also repeat implementation and maintenance activities within new prototype versions. The traditional methodology used to develop, maintain, and replace information system. 5 main steps. The system development life cycle is sometimes called the waterfall approach. The output from one phase flows down to the next. But as you can see, it is also a cycle. At any stage in the process, it is possible and sometimes necessary to return to a prior stage. This is called a cycle because it is iterative in nature. At any step, you may need to go back to a previous step. Planning is a preliminary understanding of business situation, enterprise model, and conceptual data model. Analysis through analysis of business situation, reading to functional requirement, detailed conceptual data modeling, designing data logical and physical database design to develop technology and organization, implementation, writing program, building databases, testing, installing, training, and documenting. Maintenance, there are monitoring, repairing, and enhancing. From Figure 1-A, database development activity during the system development life cycle. The first step is planning, which involves enterprise modeling. In early conceptual data modeling, this is high-level planning, most likely creating enterprise-level models, not project-level. After planning comes a more in-depth study called analysis. The data models developed here are more detailed project level, including more entities, attributes, and relationships than the enterprise model. Analysis includes detailed study, interviews, requirement elicitation, and document review, as well as studying the current system. The output from this involves a detailed set of specifications for what the desired system should do, whereas analysis involves identifying what the system should do. The logical design is concerned with specifying how the system is going to do it. From a database perspective, analysis involves drawing the various entity relationship data models, whereas logical design involves defining the tables, screenshots, metadata, etc. of the finalized system. After logical design comes physical design. This can include the development or acquisition of application program. From a database perspective, we have decided on the physical database platform. Example, Oracle, SQL Server, MySQL. And written much of the SQL for creating and manipulating our data structure. Often physical design and implementation overlap. There's still programming and more SQL that takes place during implementation. But other activities include installing the finished product under production environment. Previously, it was only in test, and also preparing user through documentation and training. At the end of implementation is when the system is actually up and running. After implementation comes maintenance. This is physically by far the longest phase, because maintenance rests throughout the lifetime of the operational system. During this time, there will be needs for enhancement, bug fixes, and problem solving of various sort. Sometimes you can think of enhancement as many system development life cycles that produce the needed improvement to the system. Over the course of a system's life, maintenance may involve many miniature system development life cycles for enhancement, features, or versions. Alternative information system development approach. Traditional system development life cycle. It is methodical and structured and time-consuming methodology. And rapid application development is faster and more adaptive, especially when a database is already in place. Also, there are another one, prototyping, agile methodology, streaming programming, Scrum, dynamic system development methodology. Agile software development emphasizes individuals and interaction over processes and tools. Working software over comprehensive documentation, customer collaboration over contract negotiation, and response to change over following a plan. Figure 1-9, the prototyping methodology and database development process. Prototyping takes a different approach to system development than traditional system development lifecycle. It is less formal and more ad hoc, involving iteration of coding and using and involving. The concept of prototyping has evolved into several rapid application development variations. Unlike the traditional system development lifecycle, there is less of an emphasis on upfront planning and analysis and more of an experimentation flavor to the development process. Prototyping involves problem identification resulting in initial requirement. Then a prototype is built. This prototype is used and refined iteratively for a period of time. If the prototype works well, it becomes the de facto operational system. If the prototype doesn't work efficiently, it is converted to a more efficient operational system. Figure 1-10, 3 schema architecture. The term schema here refers to the view you have of the system being developed. Users of a system have one view based on the report, forms, and interaction they will the system. Designers have a view of the entities, attributes, and relationships involved in the world being modeled. The conceptual schema, as well as a view of table, fields, and primary and foreign key, together with an understanding of what makes a database well structured and efficient. The internal schema. If you are a database designer, you will be extensively involved in the logical and physical pieces of the internal conceptual schema. You will be particularly involved in the physical schema if you are a database administrator. If you are a user, These schema don't matter much to you. Rather, you will be involved in the external schema. So different people have different views of the database. External schema is the user view. It must be a subset of conceptual schema. It can be determined from business functional data entity matrix. Database administrator determines schema for different users. And then conceptual schema. It must be entity relationship models. And then internal schema. It is logical and physical structure. And then managing people involved in database development. Project management is an important skill in any information system project, and managing the database design and implementation task is part of project management. Projects often are organized into tasks and subtasks, each of which is scheduled for an expected time period and assigned to various people involved in the project. It is up to the project manager to monitor the process and cost of the project. So actually, project is a planned undertaking of related activity to reach an objective that has a beginning and an end. The initiated and planned in planning stage of system development life cycle, and then it is executed during analysis, design, and implementation, and closes at the end of implementation. Database project team member. There are many different people, each with different perspectives, skills, and needs involved in a system development project. So business analysts analyze business situation and establish requirement. System analysts, like business analysts, but also have technical expertise for overall information systems. Database analysts and data modelers, analysts who focus on database, users is the customer communicate their needs to analysts, programmers, coders of the program that interact with the database. Database architects establish standards for data in business unit. Data administrators responsible for existing databases, ensuring data integrity and consistency. Project managers oversees the project, manage the personnel. Other technical experts, network operating system, documentation, etc. Evaluation of database system. Driven by four main objectives. Here are some of the motivations that led to the evaluation of database system. Need for program data independence in order to reduce maintenance. Next one, desire to manage more complex data types and structures. Next, ease of data access for less technical personnel. And final one is need for more powerful decision support platform. Figure 1-11, the range of database technology, past and present. Evolution of database technology. Over the years, since the advent of computer data processing system in business, there have been many approaches to database technology. We already discussed flat files and their problem. Only attempt to solve this problem led to hierarchical and network databases. Legacy system, those initially created in the 1950s and 1960s, sometimes still use these early technologies. The relational database is the most common form, especially for business application. However, others also exist, including object-oriented and object-relational. Data warehousing is commonly used for managerial decision-making. And then nowadays, big data. Database architecture. The hierarchical and network database model were the earliest attempt to structure data according to relationship between entities, but they fell short because they were very inflexible. For example, many-to-many relationships are impossible in hierarchical databases, and although they are possible in network model, they are difficult to modify in these structures. The relational model is the most ubiquitous and represents relationships as primary to foreign key association in different relations. Here we see some confusing terminology. There is the concept of relationship, which was shown as line between boxes in figure 1-3. And there is another concept of relation, which is really like a database table. We will see this distinction later in this book. Object-oriented databases are interesting in that they allow for a sort of inheritance between classes and subclasses. Also, unlike relation table, in relational databases, object-oriented databases are capable of behaviors, program code in the form of method. If you can take a course in Java or another object-oriented language, you will become familiar with this idea. Also, if you took a course, Financial Information System, you already studied object-oriented concept. Multidimensional models are typically based on data warehouses and are used for decision support purposes. The star schema is a physical data warehouse structure. It's still a relational database, but here there are two types of table. Fact table contain numerical data that can be aggregated: prices, sales, revenue, payment, etc. Dimensions are different ranges by which you can slice and dice the numerical data, customer, department, product, time period, etc. The terminology or line analytical processing refer to the types of system that use multidimensional data. Big data is an emerging concept and opportunity for business. This refers to the huge amount of often unstructured data such as tweet, customer review, blog, email, Facebook, etc. that are increasingly important for business decision making. The VS, volume, velocity, variety, veracity, and value are big buzzwords in the big data world. The range of database application. First one is personal database. It is typical size in the megabyte. It intended for one user. And then departmental multi-tier client-server databases, typical size in the gigabyte, intended for several users, usually doesn't exceed 100 department-wide. Enterprise applications, typical size in the gigabyte, terabyte, or even petabyte, intended for a very large user base company-wide. Figure 1-12, multi-tier client-server database architecture. Most web client applications follow the three-tier approach. Databases are typically at an enterprise tier. Application program code is at an application web tier, and user interface for different users are at the client tier or presentation tier. And then types of enterprise application. First one is enterprise system, typically involved the relational databases. It is backbone of an organization. Usually we use enterprise resource planning, ERP system, customer relationship management, CRM, supply chain management, SCM, human resource management, and payroll. Data warehouses typically involve relational databases, integrate data from multiple data sources, maintain historical data, help identify patterns and trends. Data lake often don't involve relational databases, large integrated repository for internal and external data that does not follow a predefined schema. Figure 1-13, an example of an executive dashboard. Figure 1-13 presents an example of what an output from a data warehouse might look like. So you can see it is like just easy understanding dashboard. So usually not complex, graphically easy captured graphic. So you can see there are some kind of geographical and then line graph and then roughly monthly performance. And fine value furniture. Fine Valley Furniture is a functional furniture company. We will use this company as a case throughout this semester. Chapter 1 topics include database evaluation at Fine Valley Furniture Company, project planning, analyzing database requirement, designing the database, using the database, administering the database, and then future of databases at some organization like Vine Valley Furniture. Thank you for first class. See you next time. I will explain your assignment in our class. Have a great day. Bye.